Namaste, this is JV Dr. Vishal Saxena, Associate Professor in Mathematics and Statistics in Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to discuss on the module Standard Error. This module is a part of the course Biostatistics under the program of MSc NND, MSc Microbiology, MSc Biotechnology and MSc FSC first semester of the university. This topic of standard error is a very important part of the subject biostatistics and also a very important component, also a very important part of the subject research methodology. And here we will discuss about the part of the standard error and how can it be generated and how can we determine. So the standard error is just related with the statistical approach, statistical hypothesis testing, and in the today's session we are also going to discuss about the type 1 and type 2 error of hypothesis testing. So these are the important parts because when we just test or when we just do a hypothesis testing, then some errors will be generated, and by taking the null hypothesis and alternative hypothesis and with the statistic of the sampling distribution. So these are related with the hypothesis testing and the sampling distribution. The standard error can be defined as it is a standard deviation of the sampling distribution. It is a standard deviation of a statistic for a sampling distribution, while the errors of type 1 and type 2 errors are defined for the hypothesis testing, and in the type 1 error we can define it as when the null hypothesis is true but our test rejected this null hypothesis, then a kind of error is generated and this is called the type 1 error, while the type 2 error is a kind of the error which is generated by the phenomena when a null hypothesis is not true, means that is false, but our test which we have applied, so our test will accept this, then the second type of error is generated. So in today's session we are going to discuss about the mathematical concept, and we will take some examples to understand this the concept of the standard error, and which is related with the standard deviation of statistics for a statistical distribution, and how can it be obtained. We are going to see this with a numerical, with mathematical approach. So we take some slides today to explain this. Initially it is defined as in statistical test theory, the notion of the statistical error is an integral part of the hypothesis testing. So means the statistical error will be an integral part of the hypothesis testing and it will be generated there. The test goes about choosing about two competing propositions called null hypothesis denoted by H0 and the alternative hypothesis denoted by H1, and it is conceptually similar to the judgment in a court trial. So we will explain this with a court trial. The null hypothesis corresponds to the position of the defendant just as he presumed to be innocent until proven guilty. So as the null hypothesis presumed to be true until the data provide convincing evidence against it, while the alternative hypothesis corresponds to the position against the defendant. So that can be in this way we can understand the null and the alternative hypothesis. Means the null hypothesis can be taken like just where the we have to see our result. We have to check what is our the condition that and like we have seen with example that null hypothesis is corresponding to the position of defendant and just as he is presumed to be innocent until proven guilty. So until proven guilty he will be presumed to be innocent, and so is the null hypothesis presumed to be true until the data provided convincing evidence against it. So until that condition the null hypothesis will be taken as true, and till that condition when the data will just come to against it. Now we are defining the errors of type 1 and type 2. Just we have explained the error 1, the type 1 error is that error in which a true hypothesis is rejected by our test. So a true hypothesis is rejected by our test, then the generated error is called the type 1 error, and it can be understood with this example like it is corresponds to the convicting an innocent defendant. So that is the true condition, that is the true situation with the type 1 error where the null hypothesis is rejected, where the true null hypothesis is rejected by our test. While in the type 2 error, in the type 2 error, the false hypothesis, the false null hypothesis is accepted. The false hypothesis is accepted by our test, that is called the type 2 error. And the error in this condition where the false null hypothesis is accepted by our test, then the such generated error will be called type 2 error, and it is just corresponds to the acquitting a criminal. Means a criminal when acquitted, then it is like similar to the type 2 error. Now we come to the part of the standard error, and the standard error of a statistic, usually an estimate of a parameter, is the standard deviation of its sampling distribution. So it can be simplified, it can be defined as in the simple words that it is a standard deviation of its sampling distribution for the statistic. Or the statistic, if the statistic is the mean, then it is called the standard error of the mean. Now we have some characteristics for the sampling, and what are the characteristics? These are the accuracy, bias and the precision. First, the accuracy. The estimate derived from the any one sample is accurate to the extent that it differs from the population parameter. Since the population parameters can only be determined by a sample survey, hence that are generally unknown, and the actual difference between the sample estimate and the population parameter cannot be measured. So that's why the accuracy is an important part, important characteristic for the sampling distribution. Second, the estimator is unbiased. If the mean of the estimates derived from all the possible samples equals the population parameter. So the estimator is unbiased if the mean of the estimates derived from all the possible samples for all the possible samples equal the population parameters, then the estimator is unbiased. And the next condition is even if the estimator is unbiased, so means when the estimator is unbiased, an individual sample is most likely going to yield inaccurate estimate, and as stated earlier, inaccuracy cannot be measured. However, it is possible to measure the precision. That is the range between which the true value of the population parameter is expected to lie, using the concept of standard error. Now we have some very important part of this standard error, and standard errors provide simple measures of uncertainty. So standard errors provide the simple measures of uncertainty, and these can be used because first point, in many cases if the standard error of several individual quantities is known, then the standard error of some function means when the standard error of several quantities, individual quantities is known, then we can determine the standard error of the sum function related with these quantities. Second, when the probability distribution of the value is known. Second point is that in the condition where the probability distribution for the value for the statistic is known, then it can be used to calculate an exact confidence interval. Then we can find the exact confidence interval when the probability distribution of the value is known. And third point, when the probability distribution is unknown, means the opposite condition for the second point, when the probability distribution is unknown, then this Chebyshev's inequality can be used to calculate a conservative confidence interval. So in this way we can use this standard error concept to calculate the conservative confidence interval when the probability distribution is unknown. Now, what is the formula for the standard error? The standard error of the mean can be expressed as, so we are having the formula of standard error, that is sigma x bar equal to sigma upon under root n. N is the size of the sample, and sigma is the standard deviation of the population. Now we take one problem to understand this. Calculate the standard error for the following distribution. In this example we are having some data and we have to find the standard error. So first of all we have to find the mean x bar is given by the summation of data upon number of data, total number of data, that is 270 upon 5, and which is equal to 54. Now next we will find the standard deviation. So standard deviation is given by the formula of under root 1 upon n minus 1 x1 minus x bar whole square plus x2 minus x bar whole square plus till the term of xn minus x bar whole square. So putting the values of the such terms like n, the data xi and the x bar means the mean, x1, x2, x3 are the data. Just putting the values of such variables in this formula, and we will find the standard deviation is 34.86. Therefore the standard error of mean is given by s upon under root n. So 34.86 upon 2.23, and which is equal to 15.63. So that is the value of standard error. So in this way we have seen today the concept of standard error for the statistical distribution, and it is important part of this course, this subject, and students are advised to take some more numerical questions to understand this concept, and study with concept part this topic, with the concept part of the topic, and take objective questions as well because in the competitive examinations the objective type of questions will be asked. And with this I conclude my today's session. Thank you.